Okay, so we're going to be starting direct variation. All right, so today is 11/14. We are starting Chapter 3, Section 6. There are 7 sections, you guys, in this chapter. So test end of next week-ish, kind of. Hopefully I'll have that scheduled for tomorrow, but just so you can kind of gauge, we're 2 sections, there's 7 sections, so you can kind of figure out where we are. All right, so we're going to model direct variation. All right, so direct variation is a specific type of slope-intercept equation. Now, the form of it is very similar to slope-intercept form, obviously, because that's the way slope-intercept form, it is a type of slope-intercept form, but we don't, rather than having a slope, all right, so slope-intercept form is y equals mx plus b. Direct variation is y is equal to a times x. In some books, I'm going to put in parentheses, it's y is equal to k times x. I don't know why your book is different than other books or why there's a variation. But if you see that, it's the same thing. Yes. Maybe I didn't see. All right. Now, visually, if we compare these, let me rewrite this so there's something next to it. Nothing's next to it. We have a coefficient of our x. I'm going to get back to that in a second. So we have a coefficient to our x. All right. Visually, what is different between the two? I'm going to put versus, just so you can tell that we're comparing these. What's the other difference visually between slope-intercept and direct variation? Visually, what do you notice, Al? Yeah, what is the B there? Yep, so that B is our y-intercept. The interesting thing about direct variation is there really is a B. Tell me, what does the B mean? What does the y-intercept mean? If you're graphing a slope-intercept equation, what does the y-intercept really mean? Come on, you guys. If you were graphing this, if I gave you a slope-intercept equation and you graphed the equation, what does that y-intercept mean? Lily? It is where you start, but where's every y-intercept? It's on the y-axis, so it's where our line crosses the y-axis. How many of you guys would agree with that? Okay, so our y-intercept is the location the line crosses the y-axis. If I was to tell you there is a y-intercept for a direct variation, if you were to look at this equation, what would you say is the b value? Rafaela? 0. We could kind of do like a plus 0 here. So there is our y-intercept. So this is something to know. So the graph of every direct variation equation goes through the origin. So the graph of every direct variation equation goes through the origin, every single one of them. All right, so what I want to do is I want to let's label, I told you we go back to the coefficient. In our slope-intercept form, what is our coefficient called? In our slope-intercept form, what is the coefficient of my x called? Joseph? It is m. What's it called? So that's our slope. Our coefficient in direct variation is the constant of variation. So instead of slope, it's called the constant of variation. I mean, you could use it as slope. You could make any direct variation equation. You could treat it as a slope-intercept form by having your y-intercept as 0, 0 and using an a as your rise over run. You can do that. All right, but there's an easier way that you can graph those as well, and we'll get to it. All right, so what I want to do first is I want you to tell whether the equations are direct variation. I'm going to write dv for direct variation or not. So that's the first thing I want to do. I want you to be able to identify visually a direct variation equation. All right, so I'm going to give us two examples here. My first example is 2x plus 3y is equal to 0. Well, for me to determine if this is a direct variation equation, what should I do? I want you to think back if I gave this to you and said, turn this into slope-intercept form, what would you do? So what am I going to do to determine if this is a direct variation equation or not? Giselle? Get the y alone, right? So I'm going to go ahead and add a negative 2x to both sides. And then I'm going to divide everything by 3. So I get y equals negative 2/3 times x. Is that direct variation, and why? Is that direct variation, and why? L? Exactly. So here we have, I'm just going to write it is in the form y equals ax. There's no constant. All right, how about this one? Negative x plus y is equal to 4. Determine if that's a direct variation or not. I'm going to say yes for that first one. Tell me what to do. Go ahead, Rafaela. Okay. Okay. Excellent. Not direct variation because there is a constant. Are you guys cool determining whether direct variation or not visually? Okay. So I want to graph this. So I want to look at the graph of direct variation equations. We're going to use our slope-intercept model to help us, but then I'm going to show you an easier way for us to do it. Okay? Who needs to see what's up there? Okay. All right, so let's graph direct variation equations. All right. I'm going to first do this, I'm going to show you how to do it, or graph like a slope-intercept equation. I'm going to put a 1 here, just so we can see how this works and if there's an easier way that we can do it. All right, so let's do y is equal to 2/3 x. Okay, so if I was to graph this like a slope-intercept equation, what are the two things I need to graph? I need to be able to graph. What do I have to identify from that equation to be able to graph it if we're graphing it using slope-intercept form? Carmen? Excellent. I have my y-intercept and I have my slope. Carmen, what's my slope? Excellent. What's my y-intercept? Excellent. 0, 0. All right, so remember, slope is rise over run. All right, for me to graph this, this is a quick review. For me to graph slope-intercept form, what do I graph first? Rita? Y-intercept. And then what? So I'm going to go up 2 and over 3, up 2 and over 3. And then I'm going to draw my line. How many of you guys are cool with that? Al, you have that look on your face. Well, I'm using my rise of up 2 and my run of over 3. Does that make sense? I want you checking me always. All right, somebody tell me, what do you notice about our first point that we found? What is the first point we found? Giselle? No, other than the origin. After one slope, what's the first point that we found? Yep. Someone tell me, what does rise mean? In our slope, what does rise mean? Joseph? How much go up or down, right? So this rise is our change in our y. How many of you guys agree with that? All right, what is my run? What does that mean? What does that mean? Lily? It's my change in my x. Do you notice anything between your slope and your first point? Do you notice anything with regards to that slope and that first point? Maya? Be more specific. Kind of. So that 3 is my x value. That 2 is my y value. No. I know you're thinking that because you're thinking the order is top to bottom and left to right. But I want you to focus on that. Raphael? How many of you guys notice that? That is exactly what this is. All right, and I'm going to show you why in a second. That will always be the case. This first point will always be your y is your numerator, your x is your denominator, always. All right, There's a reason for that. I want you guys to take your equation, y equals ax, and I want you to solve this for a. What do you guys get? So I'm going to divide both sides by x. What do you get your a is equal to? Natalie? Y over x. So this a value, this gives us another point on the line. So our first point is always 0, 0. This is our second point. So whatever our a is, that is the coordinate point. So when I had a is equal to 2/3, my coordinate point is 3, 2. Always. So to graph direct variation, I don't need to do my slope work. I don't need to find 3 points. All I need to do is graph the y-intercept and use my a to find my second point. All right, so now you have 2 ways. If you can't remember that, you can always rely on your slope-intercept. All right, so my second method in graphing is use the y-intercept and the coordinate point from the a value. You only need to graph those 2 points. All right, so let me give you another one that I want you to graph, and I want you to keep that way in mind. Are you guys good so far? Okay. Who needs to see what's up there? Okay, so I want you to graph negative 1/3 y is equal to x. So graph negative 1/3 y equals x. So my first tip is put in direct variation form or slope-intercept form. Those two are that's the same process. All right, what am I going to do to start this? Come on. I need to put this in slope-intercept or direct variation form. I need y equals. What am I going to do that? Oh my goodness, please. This should be the easiest part of what I'm doing. How do I get rid of multiplying by that coefficient of negative 1/3? Ashley? Of what? Absolutely. I'm going to multiply by its reciprocal of negative 1/3. Because I need to get rid of that multiplication of a negative 1/3. So I'm going to multiply it by negative 3, so I get y equals negative 3x. Or y equals negative 3 over 1x. So what are my 2 points that I'm going to graph this equation? What are my 2 points that I'm going to graph this equation? Rita? Absolutely. Remember, my a is y over x. Here it's negative 3 over 1. So I have 0. Negative 3, 1, 2, 3, positive 1. Right? I have a no. This is going to be, 1 comma negative 3. So 1 and then negative 3. I did that wrong. And there is my graph. So you have 2 ways that you could graph direct variation. You could graph it as a slope-intercept, where that negative 3 is negative 3 over run. It's your rise over run, starting at the origin. Or you could be like, well, no, I know a is y over x. Just write that as a coordinate point and graph that point. Either way is fine with me. Are you guys cool with that? Awesome. Okay. So let me ask you guys something. These are all direct variation equations. Y equals 3x. Somebody else give me another one. Anything. Give me any direct variation equation. Make one up. Carmen? Y equals 10x. Rafaela? Someone else give me one. Rita? Negative what? 2/4 x. Somebody give me another one. Doesn't matter what it looks like. I mean, it does, but doesn't matter what number you use. Give me another one. Al? What's the difference in all these? What's the difference in all of these direct variation equations? What's the one thing that sets all of them apart from the other ones? Seamus? The what? They do. They all have a different constant of variation. So here, they all have different constants of variation. V-A-R-A-T-I-O-N. They all have different constant of variation. That A term, that coefficient. So, to write a direct variation equation, whether it's from a graph or a story problem, all you need to do is find A. That's it. You don't need a y-intercept to find. You don't need an initial value. You don't need any of that. All you need to find to write a direct variation equation is your A value. So, to write a direct variation equation, all you need to determine is the A value. Tomorrow we're going to focus on story problems. Today, for the rest of this next couple minutes, we're going to focus on graphs. Okay? So I'm going to give you a graph, and I want you to write the direct variation equation from the graph. Okay? Who needs to see what's up there? All right. Write a direct variation equation for the following graph. All right. Remember, always start with a generic form. What is the equation for A? What's the formula for A? Rita? Excellent. State that. When you're done, check with someone sitting by you. All right, someone tell me, what's my A value? What is my A value? Come on, you guys. Anastasia, what's my A value? 3/2. What's this coordinate point? Positive 2 or negative 2? So negative 2 comma 3. So what's my A value? 3/-2. Oopsie, this should be X, not A. So someone write my equation for me now. Or Anastasia, finish writing this. What's my equation now then? X, right? So where the negative goes doesn't matter. A lot of times you're going to find it just outside the whole, like in front of the whole thing. It can either be on your numerator, your denominator, or just out in front. All right, now what I want you to do is I want you to find y when x equals 20. When you're using it in calculations, put the negative on either the numerator or the denominator. So what is my y value when x equals 20? L? Negative 30. You guys cool with that? Okay, so I'm going to give you two things that I want you to do. I want you to graph y equals 2/5 x. And the next thing I want you to do is I want you the graph of a direct variation equation passes through. The point 4,6. Write the direct variation equation. And find x when y is equal to 36. So this is a little twist. Go ahead and do those, please.
Teachers and students, please pardon the interruption. I'd like to wish a happy birthday today to Megan McMichael and Mia Ramos. Happy birthday today, Megan in our 5th grade and Mia in kindergarten. Although we don't have any student birthdays tomorrow, we would like to wish tomorrow a happy birthday to Mrs. Bajungan. Happy birthday tomorrow, Mrs. Bajungan. At this time, I'd like to call down to two students and congratulate them on our STEAM Day design, and that is Emerson Turcott and Megan McMichael. Congratulations, Megan and Emerson. You can come down now and claim your art surprise for our STEAM Day. A reminder that tomorrow is STEAM Day. Teachers, make sure to check your itineraries for tomorrow. We will have some different lunch, recess, and some different scheduling times for tomorrow, so please be prepared for that. Students, it is a normal dress day tomorrow, so students wear your normal uniform for tomorrow. At this time, we would like to recycle, so those students that normally recycle, please recycle now, and please make sure to try to get all areas of our school. Pardon this early interruption today. Those are your announcements for this Thursday. Have a terrific rest of your Thursday, and would Alex Madney and Alexander Raban please come down to the main office now. Once again, Alex Madney and Alexander Raban come down to the main office now. Thank you.
When you graph that first one, please tell me the 2 points you graphed. It's always going to be 0, 0, and then tell me the second point. Help each other out. If you have questions, ask each other, check with each other. So on that first one, identify the 2 points you're graphing. The 0, 0, and the other point that you're getting from the equation. And you only need 2 points. Okay? If we do slope-intercept form and you deal with rise over run, that's fine with me. But I would like you getting used to just seeing what that second point is from our A value. You got that look on your face again. Read the first one. So there's 2 you're doing. First of all, you're graphing y is equal to 2/5 x. And the second one, you don't have to graph the second one. You can, but you don't have to, because from the graph, all you're getting is that point to find your A value. So you guys should have found that our 2 points are 0, 0, and then 5, 2. How many of you guys agreed that that was what our second point was? All right, so that's all I need are those 2 points. 1, 2, 3, 4, 5, 1, 2. So that really is that simple. I know you guys are thinking it should be more complicated than that, and it's just really not. That's it for direct variation. And that second one, remember, your A value is what you need to determine to write any direct variation equation. So how do I find my A value? If I'm given a point, how do I find my A value, Natalie? It's y over x. So what's our A value, Natalie? 6 over 4, and simplify that. What does that simplify to? 3 over 2. So what's my equation, Natalie? No. Write the equation first. Excellent. So there's my equation. And now I'm going to evaluate it when x equals 36, or y equals 36. Always write the equation first and then use it. All right, so now what, Natalie?
36 equals
All right, solve it for me.
So
Excellent. That's 12, right? So I get x is equal to 24. Yes? Well, that's not a simplified. I want that simplified. So let's make a note here. Always simplify the a value. Regular fraction, improper fraction, integer. That's a great question. I mean, you'll get the same answer, but usually when we're writing equations, we want those to be simplified. Does that make sense? But you would get the same answer. All right, Monday we're going to see what this looks like with the story problem, because nobody's going to walk up to you on the street and have you do this. You have to kind of know when it applies, right? And how to know when you have a direct variation equation, okay? You go to school? All right, that's it. That's all I got for you.